Next is the scalar triple product. Like ordinary two vector products, these vector product is also classified into two types of product. First one is scalar triple product and second is the vector triple product. In the first, we will try to explain about the vector triple product. The simple definition of vector triple product is that if we multiply three vectors and resultant is again a vector quantity, then the product of three vectors is called vector triple product, and written as for three vectors A, B, and C, A cross B cross C, because B cross C will give a vector, and vector multiplied by vector A, that is again a vector quantity. So we call these as a vector triple product. We will discuss in the next section some examples about the vector triple product. Now, mathematically, this product can be interpreted as we need at least two planes, because here two times multiplication process is involved. Like this one, B cross C. First of all, we will multiply B cross C, and the resultant of B cross C will be multiplied with vector A. Here is a diagram to explain these two cross. For example, first of all, we will describe plane X, Y, and Z. A plane is drawn between X and Y, and another plane is drawn between Y and Z. So first of all, we will try to explain B cross C. To make the product of B cross C here, B and C as a cross, B is only have one component, that is known as Bx. I like this one. Similarly, again, vector C include two components, one along x-axis and another along y-axis. So vector C have two components, Cxi and Cyj. And third one is the vector A, that is simply in the next section and involve three components, Axi, Ayj, and Azk respectively. In order to explain the mathematical interpretation, first we need product of B and C. Let we multiply B and C by a determinant method. Here we write I, J, K, because B is only equal to Bxi and Y is 0 and Z is 0. So 0, 0. Similarly, C is equal to Cxi, Cyj plus 0K, and here is a 0. Now we will multiply these first row, first column, and these two product will give the 0 result. Similarly, first row and second column, then these two quantities again give the 0 result. The first two term will be 0 and we will get the last term, that will be the remaining only along z-axis. Now this is need to multiply with vector A. So we write here I, J, K, and the components of vector A are Axi, Ayj, Azk. And B cross C here is 0i plus 0j and Bxcyk. Again, we will multiply by using first row and first column, this one and this one. Second term will be the 0, and we will get these three components. Similarly, first row, second column, these will give again one quantity is equal to 0, and third one, first row with third column, these two terms will be the alternatively 0. Now, this is incomplete because here only A, Y, B, X, C, Y, I, and J components involved. No third component is present. That's why we will try to add and subtract AX, BX, CX, I. Like here, I am going to label. This is the term which is we subtract and add in the above result. Now taking again rearrange, first we write positive term and then we write negative term. Now we will take common here from bx and here from ax and bx. We will get this one. Now a dot c, this is equal to ax cx, ay cy and 0. This is equal to a dot c and this is equal to the vector b. This will equal to a dot c into b like this one, and here this is equal to ax bx. Here we have mentioned that is equal to a dot b, and this is a simply vector c. So a cross b cross c is equal to the product of a dot c into b minus a dot b into c.